So we're working at solving absolute value equations, and we get to this problem, and we're going to solve this algebraically. So using our steps to solve absolute value, we're going to isolate the absolute value by moving the 3 to the other side. So now we have the absolute value of x plus 2 is equal to 1/2 x plus 4. And if we want to solve this algebraically, the rule for absolute value, we take the part that's inside, set it equal to the positive 1/2 x plus 4, and then we take the absolute value and set it equal to the negative 1/2 x plus 4. Be sure to use parentheses when you're solving this problem so that we make sure everything is negative. Okay, and then we're going to solve this equation. So over here, I'm going to move the x to the same side, so I'm going to subtract the 1/2 x, and I have 1/2 x plus 2 equals 4, and I minus the 2 from both sides, and I get 1/2 x equals 2, and I get rid of the 1/2, I'm going to multiply by 2. So I get x equals 4 as my solution. And then for my second case over here, first I have to distribute the negative sign, so we get negative 1/2 x minus 4. And now I'm going to move my x to the same side by adding 1/2 x. And in doing so, I get 3/2 x plus 2 equals negative 4. And I'm going to minus a 2 from both sides. So 3/2 x equals negative 6. And to get rid of the 3/2, I'm going to multiply by the reciprocal, 2/3. And that gives me x equals negative 4. And I get my two solutions. So now I'm going to do the same problem graphing. So if I'm doing this graphically, my first equation is x plus 2, the absolute value of x plus 2 minus 3. And my second equation is 1/2 x plus 1. And I set up some table of values here so we can use a table of value. So to graph the absolute value, remember we start with what's inside and we set it equal to 0. So x equals negative 2. We're going to use that as the center of my table. And I pick my values less than and my values greater than. Oops, sorry, that's supposed to be a 1. I was thinking ahead. And now I'm going to plug these in. Negative 4 plus 2 is negative 2. The absolute value is 2. 2 minus 3 is negative 1. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is 1. 1 minus 3 is negative 2. Negative 2 plus 2 is 0. Absolute value of 0 is 0 minus 3, negative 3. And then we get our reflection, so this will be negative 2, negative 1, and then the final answer, 1 plus 2 is 3. 3 minus 3 is 0. So I plot these points. Negative 4, negative 1, negative 3, negative 2, negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, 0, and I should see my absolute value graph forming here. The second equation is a line, so we can use a table of values or we can think slope-intercept form. We're going to begin at the 1, and we're going to move down 1 and over 2, down 1 and over 2. And then we're going to continue that. Sorry, I don't know why I said down 1. We're going to move up 1 and over 2. It's positive. Up 1 and over 2, up 1 and over 2, and then move in the other direction, down 1 over 2 in the other way. And if we graph that line and look for our intersection points, we notice that they intersect at x equals negative 4 and x equals 4, the same solutions we got when we solved this algebraically. So there's some follow-up questions that you can answer. When does a graph equal? And it's at the intersection of the functions. Okay, and that's where they meet. And then it says it's an intersection point, an element of f, an element also of g. Do the functions f and g really have the same value? And the answer is yes. They share the same value at those 2 points. Are the x coordinates